We're here to talk about these things, EVSEs. These are what you use to charge your electric vehicle. But they are not, in fact, electric vehicle chargers. On all modern EVs, everything sold around the world really today for 2022, the charger is built into the vehicle itself. And these things, the things that you plug into your dryer outlet, or you plug into your RV plug, or you plug into your window AC plug, or whatever kind of plug you've got on the end of your EVSE, is more or less an over-glorified smart extension cord. These guys tell the car what kind of power is available, and then the car is responsible for charging itself. There are a few other minor electronics built into these devices. They may or may not have a ground fault interrupter circuit to help reduce the risk of electrocution in wet weather. It's not required for all EVSEs, although it is highly recommended. And they may or may not operate on 240 volts or 120 volts. It just depends on the EVSE. But let's take a look at them. The only truly essential component for an EVSE in America is this connector right here. It's a standard J1772 charging connector. This is the one that every EV except for Tesla currently in the United States uses. It has a locker right there so that we can actually lock into the vehicle, helps keep it from pulling out accidentally, and it has a little tab in there so that way the vehicle can actually put a locking pin through there and prevent its removal from the vehicle until the vehicle itself is unlocked. The circuitry inside an EVSE is so simple that there are actually available EVSEs, generally for level 1 charging at 120 volts, that have the entire electronic component integrated into the handle itself, and the other side just has a plug on it. But that doesn't cover the 3 EVSEs that I have here. Let's go over what these 3 are. First, the one that you'll find in a new electric vehicle. For instance, this Ford EVSE right here. This one came with the long-term Ford Mustang Mach-E that we currently own. On the back of this EVSE, you can see that we have a voltage rating. This one is a dual voltage EVSE. It'll operate on either 120 volts or 240 volts, maximum of 32 amps. It's automatic for this particular one, so you can see right here we have a 120 volt plug on the end of it. If that's plugged into it and it senses just 120 volts available, it's going to operate in 120 volt mode up to about 12 amps. The really nice touch with this standard EVSE is that even though it cannot charge the vehicle at its maximum charge rate, the Mach-E will suck down more than 32 amps, 240 volts. This plug end is removable, so you don't just have to charge at 120 volts, you can charge at 32 amps, 240 volts with this connector right here. This has an L1450 connector right there on that side, and then this is the connector that snaps in and out of this EVSE. You simply pull that out, and then we pop this plug right in there, and then the EVSE gets 240 volts and it knows it will charge up to 32 amps. But this EVSE is not smart. So say you wanted to plug it into a 30 amp locking 240 volt outlet. That's what this little adapter would do. I mean, you could plug that in with this adapter and then plug it into the wall, but the car is going to try and pull more than 30 amps through that circuit. Same statement would apply if I wanted to go for a 240 volt 20 amp plug of that variety, the locking kind, or the non-locking variety there. That's where an adjustable EVSE comes in. I managed to get this one off eBay really cheap a number of years ago. I have no idea whether this one is even sold anymore. This one is adjustable because the one thing that the EVSE is responsible for is telling the vehicle how much power it can pull through the J1772 connector. If it wasn't for the EVSE, vehicle like the Ford Mustang Mach-E or the Model Y or a Model S would pull more current than this connector is capable of if you plugged it into, say again, a window air conditioning outlet. Many electric vehicles and plug-in hybrids will allow you to adjust on an on-screen menu how much power is being pulled down when it's plugged into a 120 volt outlet, but 240, I have never seen one, although theoretically it would be possible. Instead, that's what the EVSE is for. It's to tell the car, hey, you can pull 30 amps, or 40 amps, or 48 amps, or up to 80 amps. That is the maximum design capacity of the J1772 charging connector. Anyway, back to this EVSE. What's cool about this one, and you can find similar ones online, is that when you first plug it in, you can then shake this. You have to actually shake it quite violently, and then it will cycle through different power levels. On the front of this EVSE, there is a little LCD as well as some diagnostic lights. That's kind of handy. On the back, as you can see, it will do 6 amps up to 32 amps maximum 120 or 240 volts. The reason I got this EVSE is that it supports 12 amps 240 volt charging, 16 amps 240 volt charging, 24 amps, and all the way up to 32 amps. So you can plug this into a 20 amp 220 volt circuit or a 30 amp or a 40 amp circuit and charge your EV. Now the reason this doesn't go 20, 30, 40 amps is because in America, you're only supposed to load the circuit to 80%. So this is only supposed to draw 80% of the circuit breaker rating in the cabinet. So if your circuit's a 20 amp circuit, it's supposed to pull 16 amps max. Adjustable EVSEs like that are the reason that we have so many available adapters out there for EVSEs, because, very clearly this connector at the end here is not rated for 32 amps like this end here. This is actually rated for 50 amps on that side, but in order to plug it into a 30 amp circuit or a 20 amp circuit, you would need to adjust the EVSE. Now, next up, to show you just exactly what's inside an EVSE, I have an open EVSE. This is one of my favorite companies out there currently doing EVSEs simply because of the design of it. You can see what's inside, and if you wanted to assemble it yourself, you can actually do that with them too. And you can buy lots of different EVSE components, new connectors, new cables, etc. if you want to DIY. But let's pop the cover and see how simple an EVSE really is inside. Over here we have the circuit board for the LCD up front. This is a backlit LCD and it will give you charge status right there. Over here we have a Wi-Fi board. This is actually pretty similar to the Wi-Fi card that we find in a lot of other consumer electronics that allows us to connect to the internet. There's some cables in here connecting that LCD, of course, over there. We have a very small logic board here, but mainly what's going on here is the signaling to the vehicle to tell it what kind of power is available, and this little controller module here that controls this big relay here. This is what turns on and off the power to the vehicle. For safety reasons, you don't want to start pulling power directly through the pins immediately upon insertion. You'd end up with arcing, you could damage things, and of course wear those pins out over time. So instead what happens is you plug your vehicle in, there's a little bit of negotiation happening, then this little circuit engages and it allows the car to pull power through the EVSE. There is a reason that EVSEs are not 100% efficient, and it mainly has to do with the coil right here inside this relay module and the tiny bit of power that's being drawn by the other electronics. But generally speaking, 99.9 or 99.8% of the power is going to be going from this wall plug right there and then back out to this connector over here and into the vehicle. All the rest of the efficiency lost in a modern EV happens in the charger on board. There are two reasons that I like this open EVSE. The first one is the fact that you can buy replacement parts from them. And I have had an EVSE, oddly enough, that had a relay that went bad. And due to the design of that particular EVSE, it was soldered onto the main board and it wasn't user replaceable. Fortunately, the company decided to honor the warranty that had already expired and they sent me a new one, but it was a lesson learned. So when I upgraded into this one right here that could support up to 48 amps for some of the faster onboard chargers, I decided to go for an open EVSE so I could replace this myself if I needed to. If you don't plan on charging your EV that rapidly, then some EVSEs use a solid-state relay inside that's going to have a much longer lifetime. That's what this one uses internally. But for those 48 amp charges, you're going to need something like this. The other reason I opted for this model is that there are a ton of open source add-ons for the open EVSE, so if you want to do data logging and other things, you can do that pretty easily. Now, how about if you're just looking for a solid, good EVSE for your next car purchase? Well, to be honest, if you bought a Ford Mustang Mach-E and you didn't need to charge faster than 32 amps, I would just stick with the Ford EVSE. This is a good, solid one. It's not an intelligent EVSE, but that's actually not a problem at all, because you see, again, these are over-glorified extension cords, really. If you want to start and stop the charging, why would you pull up a separate app when I could just pull up the Ford app on my phone right here? It's already connected with the car. I need it in order to drive the vehicle. I need it to start it, and I can start and stop and schedule charging right here on the app if you want to do that. And that's really the main reason that we have internet-connected EVSEs, is for that particular functionality. Now, there are some EVSEs that can do things like respond to power company requests for you to stop charging. They can monitor how much it's costing you to charge, that sort of thing. If you're interested in that, then maybe you might want to take a look at those other EVSEs, but they're going to be more expensive than just basic ones like this. Companies like Clipper Creek, they have some very basic EVSEs. Open EVSE is relatively inexpensive. Some of the juice box EVSEs are pretty cheap as well. Bottom line, I just wouldn't spend too much more because, again, this is not charging the battery directly. And I think that is a little bit of a misconception with some people that I've met that have bought new EVs recently. They want to get that fancy EVSE because they bought the fancy new car and they want one with all the bells and whistles. But think critically about it. This is an overglorified extension cord. If you want to start and stop charging remotely, your car probably has an app for that, and it probably has a built-in scheduler, and it's going to be in an app that you're already using regularly. Thanks for watching. Let me know what you think about that, and let me know if you have any other questions about EV equipment down there in the comments section below. And I would love to know your experience with EVSEs out there. Is there a brand that you prefer? Let me know down there. Hit that subscribe button if you haven't already done so. I'll see everybody next week.